So I am Govind Rangaswamy, founder and CEO of Appranix. And today's webinar is about how application environments can be recovered on the cloud at close to 80%, up to 80% less than what people have been doing, right? And also, I will highlight some of the complexities in terms of, how organizations struggle when a ransomware attack happens, and they keep, happening many, many times. So we'll explore those fundamental issues today with respect to the technologies and tools that are, available in the market, but they are not able to satisfy some of the requirements. And overall, we'll also introduce the subject of cloud application resiliency, why it is important for the organization. So a little bit of housekeeping. You do not have to really kind of record anything here. Don't worry about the slides. All of the webinar will be recorded and will be posted on the YouTube, perhaps end of tomorrow. So you'll be able to kind of take that and distribute it within your organization. Please, we request you to do so that you can also spread the capabilities of the cloud platforms as well as the technologies available on the cloud platforms to make it really useful from an application resiliency perspective. And would you be kind enough to also post it in your LinkedIn as well as Twitter and other social channels so that the word spreads? We request you to do the same. So let's get started. We categorize two types of applications, mainly in the set of applications that have been running on the data center for a while, but they're all in the process of getting migrated over to the cloud platforms, be it AWS, Google, and Microsoft. By the way, we are not at all going to talk about the capabilities surrounding what we are saying that as a cloud application resiliency, nothing to do with some kind of a private cloud infrastructure. That is not the cloud that we are talking about, a private data center or resiliency cloud. So those cloud washing terms we are not using. We are particularly talking about the hyperscale software defined public cloud infrastructure like AWS, GCP, and Microsoft Azure and the like. And the legacy applications, they've been making money for the organizations that are getting migrated for various reasons. Maybe initially the cost cutting, or maybe that the data center, one of the data centers is getting closed, or maybe because the application development teams are choosing to create the infrastructure really quickly. So for many reasons, these applications are being lifted and shifted to the cloud platforms, and they are being enabled by the cloud platform services so that they can be, can be brought up with a less cost with respect to the infrastructure, as well as quickly, so that you can build applications and move them and release the features quickly as well. But there are areas where cloud is much better compared to the traditional technology in terms of resiliency. The capabilities that were unimaginable a decade ago are now possible with cloud. So that is a part, I call that as an enablement. Cloud enables certain things to be done. Second category is obviously the modern applications that are pretty much making use of the cloud technologies, cloud platforms, cloud services that pretty much focus around the application architecture, probably much more distributed application architecture, so that the developers can release and the operations folks can actually take care of these applications quick enough so that you can release more and more features based on the customer demand. So those are kind of grouped under cloud native technology, but I could argue that even the applications that are not using containers are still cloud native because you are using cloud native services. Even with the containers, you will end up using some of the external services with respect to stateful applications. So these are, again, a combination, hybrid type of applications. In both the scenarios, right, the application model is going through a big change. Now, there is a kind of a curveball, a strike from the left field is appearing, which is basically a ransomware attack type of cyber disaster. So I'm not calling that as a natural disaster situation, obviously. This is about cyber disasters. And cyber disasters has given the way for a name called cyber resilience, which means the organization need to be resilient with respect to the cyber disasters. And there are too many of them. Even today, I came across a situation where one of the DoD contractors have been attacked by the ransomware attack, right? And yesterday there's an aluminum manufacturing unit out there in Netherlands was attacked. So it's like, and if you subscribe to any of the ransomware attack, ransomware situation, RSS feeds, you will come across, every day there is something that's happening with respect to ransomware, and they are the sophisticated form of cyber attacks that's happening. And the key thing here is that what analysts, the thinkers and the people who are listening to many of these customers probably making inquiries are also making requests, say, are there tools available? So if you look at Gartner and Forrester type of analysis, what they are saying is that you will have to really think about, right, better backup and recovery strategies. So the approach of backup and recovery, these are infrastructure terms, and that have been carried over from the data center world. And from our point of view, those terms need to be dropped. In fact, what we argue is that backup should be free, right? Backup as a kind of a technology for everyday use should be free enough so that people can make use of the data infrastructure along with the application infrastructure in a much more meaningful way. And the much more meaningful way allows them to recover the applications really, really quickly. So that's a meaningful discussion from an application perspective. What that means is that, and what we observed from many of our conversations from customers is that organizations are wasting too much on the cloud, mainly because they are consuming unnecessarily in terms of cost. One, obviously, when they bring the legacy applications over to the cloud, they tend to bring the legacy backup solutions as well, because they have the relationship with the organizations, vendors that have been dealing with over a period of 20 years maybe, and they tend to bring these legacy backup solutions over to the cloud. They put the agent and make it unnecessarily complex, and they pay too much for that, and they don't function properly as well. Second is that even talking about just the backup and recovery from an infrastructure perspective has become complex, because when you go to the cloud, you tend to use a lot more services, and also a lot more infrastructure than the traditional traditional data center infrastructure, which means that you're dealing with too many of these agents all over the place. So it becomes too complex, which means that you will have to really think about a different way. And even with all of that, what's happening is that if you think about an application environment, and if you think about just a bunch of virtual machines and file systems and databases and so on, people from a backup and recovery perspective, even it is sitting on one of the sites of the enterprise after the operations teams are done with real production operations. And these backup teams, they need to go and back up the systems, right? This is unfortunate. This is really what's happening is that an infrastructure and the consumption of the cloud based on so many snapshots and the data growth that's happening on the backup and recovery side, unfortunately, is being wasted so much, so that even with that protection, only 12% of the application environment is covered. Where is this network infrastructure? Right? Where is the security infrastructure? What about the connectivity between those components? Those are all the missing pieces. That's why in the situations where in Atlanta, when the ransomware attack happened, the ransomware payment was about 50 plus K, 56K to be exact. And the recovery cost and the recovery time is enormous, and more than $1 million to recover, because you need to now bring in all the people, then you have to pay for the recovery. And where would you recover? I mean, the same servers or a different server? Unbelievably expensive, which means that you will have to rethink those scenarios completely differently. And particularly when you think about this, we end up kind of highlighting every conversation that we have, because we still have long ways to go to educate people with respect to moving applications over to the cloud, and then thinking about application resiliency, not backup and recovery, right? Again, as I mentioned, backup should be free. Backup should be absolutely free. There's no point in charging for a backup, right? So, which means that if you think about it, you put a backup infrastructure, you need to self-manage that infrastructure. You need to make sure that the infrastructure is highly scalable so that you can back up more and consistently, all of that. And when you go to the cloud, what happens is that you end up putting that backup infrastructure along with your regular infrastructure in one particular zone of the cloud, right? Just imagine, because the zone is a data center. So you migrated from your data center over to the cloud provider data center in one of the zones. And then you installed the backup manager, backup infrastructure with respect to storage and so on. And then you put all your agents to every one of these virtual machines, and then you start backing up. And you're pulling the data out of the virtual machines using the cloud networking, right? The production networking, and now putting it on where? On the cloud itself, probably in one of the S3 buckets that's just specific to the region. So that's a typical infrastructure that we see. And unfortunately, these organizations are not really utilizing the cloud properly. Of course, they are wasting enormous money on this. People are trying to kind of put a governance around the cloud usage, and that itself is a big problem. We are not talking about that, but we are talking about the complexity involved in just putting an infrastructure for backup and running it. That itself becomes so expensive, and it is not commoditized yet. And you will have to take care of the backend storage because you are making so many copies, every day copy, every hour copy, every weekly copy, every monthly copy. And then you have to keep all these copies properly, which means that you need to have a large data storage footprint. And who manages that? You manage that one because you are running your production applications. And who has time for this? Second aspect that is very important from an application that is getting migrated, an organization migrating to the cloud, is that the operating model has completely changed. The operating model from the data center over to the cloud is so different. It has to be consistently deployed and provisioned using infrastructure as code, right? The old model of going and using even a wizard-based approach for creating a VMware infrastructure is a bygone era type of technology and usage, right? And the configuration management tools that enforce the configurations for those infrastructure is, again, yes, but it should be built in, which means that they are taken for granted. Looks like there is some kind of a noise coming from one of the attendees. All right, sorry about that. And what happens is that now, and more than that, it's the separation of backup and the DR systems. And that itself is a problem because, again, data center carryover mechanism or the technology here. People tend to treat the backup and restore separate from actual storage-based replication and recovery systems. So that's all now is, overall is too complex. Complex to a point where even with that complexity, you are only taking care of 12% of the application environment coverage. This is insane, right? And that is when we see, and we ask this very simple, plain question everywhere we go and everywhere we point this out: are your applications are really resilient, are really protected? And whenever we ask this question, there is a dead silence. It's as if we kind of woke them up, probably something that they need to really think about, right? And that's one of the components of it, right? The aspect in this particular webinar that we would like to really nail is that the cost of recovery. Why is that? Why is such a thing? It's because, if you think about, again, the first slide where we highlighted the ransomware recovery cost situation, where the organization spends so much with respect to recovering and spending time to recover this expensive. The expensive, even if you go to the cloud, you tend to follow the same mechanism, right? So as an example, the cost of recovery for an enterprise, if they even outsource the disaster recovery to a third-party provider. Typically, they come up with like 2 times per year you can do a testing for free, which means that the provider on the other side, they need to have enough infrastructure, including server storage and networking, all of that, and then people provisioning, getting the environment ready, racks and racks of systems ready so that you can go and test your application. Right? They can only afford like 2 times as part of the contract, typical scenario. Yeah, let's say if you outsource that to SunGuard or IBM Resiliency Services, that is the situation. But if you kind of ask for one more, let's say I would like to do every quarterly test. You might have signed the contract 5 years ago, and now the situation is so bad that you would like to actually request for more testing. And then the testing cost comes out anywhere between 30K to 50K for an environment of size, let's say 500 virtual machines, right? And that is the typical cost of the test recovery. So if it were like cost, maybe you can budget and do it. The other issue is that it's too complex to do. Even the testing environment for recovery is a project. Like you will have to assemble your team, your application team, your infrastructure team, your database team, your networking team, all of that, because it's an application environment that you have to really bring it up. And then there are too many moving parts. You don't even know what kind of connections going where. So, and even assuming that the entire data that you requested to be backed up in the recovery environment is actually backed up, you don't even know. So even in those situations, yes, you kind of understand that the problem is too complex, and the cost is also too high, right? Even if you set aside those 2 problems, by the time you kind of complete this project, you would realize that you allocated so much time, right? Time-consuming thing. For what purpose? Maybe because there's a compliance reason. But in all of these situations, right, the cost of recovery is too high, too complex, and time-consuming is kind of a very simple thing to understand. Kind of wrap your minds around it. But if you really think through all of this, and would you like to carry this type of approach, this model, this operating model, if you will, over to the cloud? Wouldn't you be thinking something different? And that's, let me stop at the question point of view, right? Because it's too hard from an organization, especially from larger enterprise perspective. It's hard. And we realize that. And especially things happen really bad from a ransomware recovery perspective, right? It becomes really, really hard because now you are trying to recover your environment really quickly, which means that if you need to have some kind of a guarantee for recovery, you should have tested the environment often, right? And that is a problem, especially when the environment looks like this, even on the cloud, right? This is a very simple 8 virtual machine environment, running on 3 different zones. So zone 1, zone 2, zone 3, one of the East Coast environments of AWS cloud. And we are going to use GCP as an example, just to give you an idea of how you can move between 2 different cloud environments and you can still see the same problem. You can see typically the backup and recovery mechanisms today will recover your instances, right? They may not even worry about the same instances running in a different zone. So 3 different zones, and they're all taking care of one application. And the architecture requirement, or at least a suggestion coming from AWS well architecture framework, is that you spread out your application infrastructure at least 2 zones, right? And bind them together using a load balancer so that you can scale when the requests come to your applications, from a performance perspective, user perspective, and so on. So, you architect in such a way that at least from a production environment, 99% availability perspective, right, you can take care, right? You cannot stretch beyond that because the infrastructure availability is only most of the time 99.5 or 99.9% from a storage perspective, except the cold storage or S3 bucket type of that you have the availability and the resiliency associated with it, which is supposed to be kind of a lot more reliable. From an application perspective, your application perspective, you are responsible for taking care of this simple environment. From our perspective, it's a simple application running is supposed to be in a data center perspective. There's only 3 virtual machines. In the cloud, you kind of spread it out. a little more so that your application can withstand some failures. And you put in load balancers, and then you connect all of them using security groups and appropriate subnet configurations, appropriate VPC configurations, route tables, all of the nice things that are really required for you to run your application. You are perfectly running, great. Now the situation is that how do you really back up this entire environment and play it back again and test it again multiple times so that you can be confident that you can recover your application environment, critical applications for that matter, when it is really required. And that time, now if you think about the cost associated with it, the complexity associated with it, the time associated with it, it's too much to handle, right? And then on top of that, now you don't have the expertise with respect to the cloud. That's assuming that yes, people are getting trained, all of that, that's great. So which makes it easier to your point. And now you have to really write infrastructure as code. Now you cannot just spin up one VM here, 5 VM there, and then group them and then spin them up. That's not going to work. You need to really write, if you want to really bring up your application environment, you need to bring up other services, which means that you need to write infrastructure as code. Now, if you go into the infrastructure as code situation, now you have to really think about nested templates, right? And the restrictions associated with all of that. So there is enough complexity here that I know some people go, this is not for me. And let me go and do my regular backup and say that this is a chore. I'm going to just back it up. I'm going to make a statement that backups are done every 4 hours. That used to be the organization requirement anyway. For compliance reasons, we are done with it. Great, thank you. I can continue to whatever I am supposed to do. But the reality is a lot more nuanced, if you will, which means that you could explore the possibility of, yes, it is possible to test your application environments, and it is possible to completely automate it, remove the complexity, the error-prone situation with it, and of course, you can test it really, really fast. If that is the case, then we come in play. Appranix gives you that 1, 2, 3 mechanism, right? Literally, actually, after subscription, you can take away that one, right? That is a one-time activity. Even the second case is after adding a bunch of policies, backup policies, protection policies, if you will, you can forget that step too, right? Really, for a day-to-day activity perspective, you could actually say we could even automate that. So pretty much you could remove 95% of that activity as well, because it's going to be a single click, right? That's all there is to it. And we'll demonstrate, how things work in a moment. And you are not alone. This has been used by larger organizations. Think about 305 terabyte today. They are running about 320 terabytes. 22 petabyte of copy data, incremental copies, snapshots, and if you calculate all of that, it's about 22 petabytes. And they're running 3,000 resources-based environment, right? So when you think about virtual machine, number of virtual machine perspective, it's about 354, but the cloud instances, resource instances, they're talking about snapshots, the VPCs, EAPs, elastic IPs, the network uncles, and customer gateways, route tables, all of that make up the entire application environment. And how do you really bring up this entire thing, right? Second one is FLO Luxury. I mean, this is a huge organization, and we are happy that we won against Red Hat and IBM in this particular account. It's really, really kind of a highlighting moment for us as a company, and the team is so proud of it. And we help them with respect to resiliency. Third is it's a smaller one running on Google Cloud, and it's a SaaS platform. They need to satisfy the requirements of large university systems so that the students can log in and do all the necessary things that this particular solution offers, and it needs to run as a SaaS, which means that expectation is that it should run forever, right? No downtime. The expectation is so bad that nowadays, whenever an application moves to the cloud, the expected outcome is that it should be always on. Literally, one of the customer asks, it should be always on whenever we move to the cloud. So the expectation is not even cutting the cost anymore. the expectation is not even releasing the applications faster anymore, right? The cloud enables, in fact, it has become a common request that the cloud enables more resiliency. If that's the case, then how do you really take advantage of that? So we help you in terms of understanding what the problems are and what is possible. So under the hood is very straightforward. Read-only access, we follow cloud provider well-architected framework. So it's all just the metadata coming to Appranix Cloud, and it runs on another cloud provider. So all the security requirements, all the architecture requirements, all of that is properly satisfied. We do not run it on our own data centers, running on, again, just like other applications migrating over to the cloud. We moved to the cloud a long time ago. We, in fact, born in the cloud company. And it is architected in such a way that it can scale horizontally as customers throw in infrastructure. So we architected with all the latest technology with respect to Kubernetes running 350 plus containers that scale out as necessary and automatically take care of the request, because we are protecting your environments, right? That's very, very crucial. So the architecture is very, very key for us. So if you think about it, your application environment may not be this complex, but we kind of highlight that, cloud infrastructure, your Kubernetes infrastructure, your application namespaces, or application environments. What we do is that with setup policies, you can create something called application environment time machine. It is that simple, right? If you're familiar with the time machine concept, you can very easily translate that to an application environment time machine, right? It's not backup, it's not recovery, just those are all infrastructure terms. All you have to do is to look at from the ability of recovering your application environments whenever you need it, along with data. And it so happens that Appranix automatically offers a backup for you using cloud native technology. So you don't have to worry about the backup. That is something that you can kind of set aside, taken care. You don't have to even pay for it, right? And then our system continuously learns from your application environment. So you go ahead, change your application environments in production the way you have been doing it. No changes, absolutely no changes. No agents are required. You simply use whatever you have been using in terms of Cloud Console to change your configurations, your API, CLI, your CI/CD tools might be changing through the pipeline. Totally fine. And you change it as often as required. No changes necessary with respect to resiliency perspective. That's the part we made it so simple. It's a no-brainer, right? So if that's the case, what can you do with it? You can achieve multiple levels of resiliency. So this is where the cloud's power comes into play. The cloud offers so much power from a resiliency perspective that is kind of an eye-opener for a lot of organizations, right? So, you run one of the zones of a region, right? It's time-consuming to even think about spreading your applications over to a different zone and making sure that all of them are connected through the load balancer. And, it could be even one-time setup. Still, it's 2 times the management, if you think about it, if you have not really kind of structured and governed this environment properly, right? Second level of resiliency is that assuming that something bad happens in one of the regions, or even for insurance purposes, or situation where I don't want to touch my production environment region, I want to bring up my test environment in another region and test it for recovery purposes, for resiliency purposes, right? I should be able to do it in a different region. And what happens then? In some cases, this large organization, particularly the insurance, the financial institutions, started asking, we should be able to protect in a completely different account within the same cloud provider. Of course, they understand the complexity associated with pulling the data out to a different cloud provider. So if that's the case, what should they do? They can completely isolate into a different domain, different account, nothing to do with their organization. They can pretty much shove the data into this particular region. Maybe you can even choose a different region. So typical scenario that we have seen is that customers run on the Virginia region, and then they kind of copy over to Ohio or California, and they want to have a copy in Oregon. Right? It's a kind of a rough picture of that you could think in terms of three different regions. Or if it is a different account, you can have it in even Ohio, but in a different account that corresponds to, let's say, a managed service provider, right? It's easy to kind of put it under somebody else's name. They will not have your data, but just managing the storage, managing the cloud environment, and of course, we make all of that possible under the hood. But they will simply become the custodian of your application environment until you really need it, right? So that is another way to look at it. And in the last scenario, yeah, of course, the industry will move towards that slowly, but at least it is now possible with containers. So if you're running containers, Appranix enables you to kind of take advantage of another cloud provider. So if you're running on GCP, for example, you could go to AKS to run your applications running on stateless container applications, right? So that is also possible. We're not talking about stateful components yet. We're not talking about virtual machines yet. In this situation, is applicable only for containers that can run in the secondary cloud provider, right? And so that is a scenario. And let's look at how you could do this at 80% and a 70% less than a typical virtual machine cost or instance cost or services cost on the cloud, right? And by the way, you can embed this into your DevOps pipeline with a single line. That particular line that I'm showing at the bottom in your DevOps pipeline will enable you to build continuous resilience for your applications, right? So let's take a look at quickly what you can do with respect to your application. So here, I'm showing an application that's protected. So let's go to this application. It's an open EMR application. It's an emergency medical records type of application. A lot of hospitals use that. You can see a bunch of patients here. So you can look at different components of this application. It's a full-blown application used by a lot of hospitals. And it's open source. That is kind of a nice thing for us to kind of use that to demonstrate. And this application runs on Google. On the Google Cloud, there's about 6 instances, not much, 6 instances based application here, very simple, nothing complex. It's easier for us to kind of show the demo, to show the power of what you can do with Appranix. And the application backend operations are, you're doing the operations on a regular basis, and those operations are, typical one that you do. So I'm going to just refresh the screen so that all of the infrastructure components are visible quickly. So if you think about it, this application is humming along, and I'm going to use this particular console here at the bottom to switch the DNS with a simple script. And I know the application itself is performing well. So what we are going to do is show you how you could protect that application environment using Appranix. It's very simple. Now all you have to do is to do a cloud connection, add a cloud connection here, and say that test connection, right? And then select the Google Cloud. And if you go with an AWS, it's the same situation. And then provide an access key using a JSON. We actually made it so simple nowadays that you can directly connect with your service account. That way, none of the keys translate over to us. So once you make that cloud connection, Appranix automatically discovers all of these instances here. So about 120 instances are automatically discovered and ready to go. So the cloud connection gives you all the resources necessary in terms of discovering the entire environment. And all we have to do is to use those resources to represent your environment as an assembly. So all the cloud resources put together is an assembly, but we are not complicating that as well. All you have to select is an entry point, which is basically just instances. So you select simply the instances. Appranix will automatically calculate all the dependencies between the instances among your services, and will automatically pull all the necessary components. So just to give you an idea, if it were an AWS, you can see for the same type of instances, you can pull network occult route table, application load balancers, VPCs, network load balancer, all of that are automatically pulled along with your EBS volumes so that your application environment is properly represented here, right? So given that the environment is protected using the policies that you can obviously input based on your organization requirement. In this particular case, there are two policies here. There is a weekly policy and a daily policy with two retentions with respect to your snapshot retentions of your application environment that make up what I call that application environment time machine, right? Over a period of time, you can go and filter by policy, all the policies here, weekly policy and so on. And also you can filter based on today or last 7 days and so on. So it gives you that time machine that you could go back and forth, right, to your last week time frame. So if you look at what's protected last week was that in the primary region, for that application, it had these many changes. You had the firewall rules, all of that might be changing. It's totally fine in terms of how that environment is provided, and then you can recover whenever you feel like. In this particular case, there is no recovery here. So let's go back and bring down this environment. So what we are going to do is to simulate a disaster and then show how you can bring up that environment for test purposes or any other purposes using your Spot instances. And the equivalent of that on the Google side is preemptible instances. And you can, how easy it is to do that kind of an environment. So let's stop all these. Let's go bring down that application itself. So the application will come down in a moment. Let's do that. And that is down. So the application, emergency medical records application. Again, think about that, right? It could be a different scenario for you in your organization applications, but this application, for all intended purposes, is completely down. Now, all you have to do is to go to one of the timelines. Let's pick the latest one, right? That's what you are thinking about. Get my application back up and running, or let me do the testing so that I can do this properly. So here, a couple of options. This is where the power of profile that you created with a preemptible recovery. So this is system defined, which is the default, which will end up using the regular instances that you can buy directly from GCP. No, Spot cost reduction, none of that. This you can define as a profile and then attach it to your assembly to recover. And so what we are going to do is to test recovery with Spot, right? Spot, and Spot is a kind of a well-known nomenclature, so we'll use that. So for that, we'll pick up the preemptible recovery recovery profile. Then we are going to select another region to do that. In this particular case, the application was running in the central region. Now we are going to recover in the eastern region. So you can see the resources that you can select. Again, we don't ask you to select all the security, none of that. You don't have to worry about all of that. The entry point for traditional applications or for container ones are the instances. In this particular case, just the instances. So, or you can simply choose the entire assembly as well. If that's the case, choose with the right options for your application, and then choose to type the recovery. We ask you to type the recovery in capital letters because now you need to understand that you are spinning up those instances, spinning up the services, right, in another region of the cloud. It incurs cost, or in situations where you are really recovering on the other side, you are also switching your application over to the cloud, right, over to the other region of the cloud. So we ask you to properly kind of pay attention to that and then hit that one button. That is all you have to do, right? All the resources will automatically come up based on you don't have to even think about the order of recovery. We automatically calculate all of that, right? And if you think about the instances that will come up here, they will appear in a moment. So the virtual machine instances, you might have noticed that note from there. It automatically, all the instances are getting started. It will refresh quickly. So let's do the refresh of it. It will come up. But meanwhile, they need to be brought up in such a way that it should be based on the cloud operating model, which means that it should be based on the cloud infrastructure as code based model, which means that it should be as native as possible with respect to the cloud. So if it is in AWS cloud, we use cloud formation that is closer to what you can imagine. We are not using any Terraform and the higher level constructs here, because these services will continue to improve. And that's very reason for it. And the complexity and the scale with which the cloud providers are learning from every one of the organizations is enormous, and they continue to make changes, improvement to the services. So 5 years ago, there was no such thing called deployment manager. 5 years from now, this will be enormously kind of sophisticated. So how would you kind of take care of that? Guess what? Appranix wrote all of this infrastructure as code. To give you an idea, it wrote the entire infrastructure as code for you at that particular point in time, right? All of that is automatically written, right? So preemptible, true. So that, which means that we are using the preemptible instance of Google platform here. So we are reducing the cost. Unfortunately, we cannot highlight the cost right now because it varies depending on the market condition and so on. But what Google promises is that the preemptible instances will run for a day, right? The worst case scenario. So you should be able to kind of get it done. And in this particular case, it only took 2 minutes. Literally, it took 2 minutes. Again, going back in time, right? I will show you that picture again. What we are going to do, the application is down. So what I am going to do is to fail over that DNS. So in this particular case, the DNS is pointing to this IP address. You can see app.openemr.appranix info is pointing to this particular IP address. So what we are going to do is to go to the cloud console and then say DNS. I might be in a different script, OpenEMR script right there. And then let's execute DNS fail over, right? That's simple. I simply fail over to the other region. Then I can see once the record changes happen, it's 148 here. So I'm going to just refresh it. And that switches over to the one that is pointing to the other region with a new, it's a different IP address. So it's all kind of done, but propagation could take a bit of time, not too much on for a small application like this. But overall, let it come up it will take a minute to kind of catch up. Let me reiterate that particular point that I made earlier, right? The cost of recovery, just translate that between what you used to do before moving to the cloud and, with a provider, third-party provider, 30 to 40K per test. Once you kind of get over to the standard contract to test for your type of situation. So if you are doing every month test, can you imagine the cost of doing that? And you cannot even afford to do that because it's too complex. And because you have to write the infrastructure code. In the case of cloud, in the case of a regular data center, you'll have to provision all of that infrastructure on demand. It is time consuming. How do you know the applications are going to come up? And what is the guarantee? Where is the data? There is the consistency of that application environment, right? So only when you have tested your applications recovery many, many times, you can then guarantee your application recovery. In the case of resiliency, in the case of many other problems that might pop up because we are running on a public cloud shared infrastructure, right? So that is where we come in, and then we give you that a single touch. And if you're using a tablet, go and touch that button called recover, and your application will come up, right? Including, in this particular case, the browser happens to have a nice cache associated with it. And you can see the EMR is pointing to a different one. So what we are going to do, now that my test is complete in about, let's say 3 minutes, I'm going to kill this entire thing. So I'm going to just reset it, making sure that you type in that nice capital letter delete, because you are now deleting. What if you were running the application in production, somebody comes and kind of deletes that entire environment, because when you create that fast, you can also delete that fast, right? So the entire thing will just go off, and can see the entire infrastructure is getting dismantled right at the moment. So all of that nice infrastructure that was created for your test purposes, it's now done, right? And your application that was kind of getting tested here, it's done as well, because it's connecting. And if you think about it, nothing will work. Just to make sure that the browser doesn't have any cache or anything, just to demonstrate, right? Okay, that's it. So the application is done. Your recovery reset, all of the infrastructure is completely deleted. So in essence, what we have shown here is that you can do the test of an application recovery at 70%, 80% lower cost than your traditional recoveries. Second, you can recover the entire application environment with a touch of a button, and type in, of course, recover. Third, you can also dismantle that. Third, it's not time consuming, right? It's almost like you can automate your point where this capability becomes kind of a high availability requirement situation as well. So in some smaller assemblies and stuff like that, if you structure it in such a way, you could blur the line between the disaster recovery and high availability, and for the entire application environment. And that's what we call cloud application resiliency. And let me put a pause here and see if there are questions. Any questions in what we had shown? And we would love to kind of have further conversation if necessary. We'll also post this entire webinar on the YouTube. Please type in Appranix YouTube. You'll get to the channel, and we keep posting all the webinars that we record here anyways. So that's it. It's not too complex. I don't want to even take more of your time. In fact, we would love to give you that 9 minutes back so that you could go and perhaps have lunch or coffee or have fun. So really appreciate your time, and thank you very much.